Hello, good morning, and welcome back to CS 492F, Futures of the World, and welcome to this second part of the presentation and vision about the future of transportation and travel, given by Dongyu Yun, Junho Park, and Min-Sung Huang. So that being said, and without further ado, please Dongyu, Junho, and Min-Sung, turn on your camera, and I'll put the spotlight on you.
Can you show my slide and can you hear me?
Yes.
Okay, then I'll start the presentation. Hello, my name is Min-Sung Huang, and continuing from the last presentation, I will now begin the second presentation on the future of transportation and travel. We have already envisioned a future where AI driving cars cruise our roads and Hyperloop traverse continents. Now, that vision has become a reality, and we find ourselves asking the next natural question: what about space? Today, I seek to explore the answer to that question. Space travel was once an unreachable dream for humanity, but now that dream is gaining the hues of reality. Companies like SpaceX, Blue Origin, and Virgin Galactic are competing to turn space into the next frontier for travel. We are preparing to journey beyond the Earth, and with this presentation, I invite you to join the commencement of that journey. The future of space travel is more than mere exploration. It is a test of our curiosity, our technology, and our bravery. And today, I'm here to embark on that journey with you. As we push the boundaries of space, watch the next frontier. It's a high-altitude balloon flight. Now, ascending 30 kilometers up, they offer a serene view of Earth's curvature against the cosmos. This is space tourism redefined, accessible, and awe-inspiring. Yeah, I skipped the last part of the video since the limit of the presentation. Then let's look higher than balloons. To where rockets soar, we've got two main ways to travel in space: a suborbiter and orbiter. A suborbital flights go up past the Kármán line about 100 kilometers high, then come back down. They give us a quick taste of space and zero gravity. An orbital flights need to go super fast, over 28,000 kilometers per hour, to stay up around Earth. That's where you find satellite and space station and all spinning silently with our planet. Both kinds of space travel change how we see our place in the stars, showing us the vastness of the universe from different heights. In this video, Virgin Galactic succeeded in a suborbital space trip for civilians. Let's look at the video.
3, 2, 1, release, release, release. Ignition. Good control. There's Mach 1. The pilots have started trimming for that turn towards space. Trim is now set. There is max Q. That's the point of maximum pressure exerted on the vehicle by the atmosphere. Those on board are experiencing about 3 Gs right now and traveling over 1,000 miles an hour.
That's incredible. I can imagine they're having quite a great time.
We're at Mach 2. We're in the vertical, headed towards space.
This is the part where they're seeing Earth move away and seeing space come into view and seeing that they're going to space, and just, it is an incredible feeling.
So we've got about Mach 2.8, Mach 3 approximately, and rocket motor cutoff.
Amazing. The crowds here are just absolutely going wild. I can't imagine what's happening in Antigua with them cheering them on. That's incredible. Awesome. Go Keisha, go Anna, go John.
So everybody on board has been cleared to unstrap and enjoy that zero-G experience. The pilots have unlocked the feather. That's the preparation so that they can raise the feather here momentarily. They're engaging the RCS as well. The feather is now starting to move on its way up. Everyone's up out of their seats. Just
oh, it's incredible. They're all, I know, it's amazing. They're all going to the window and taking in this just absolutely incredible view of Earth, the planet where all of their experiences are held. Everything they've ever known is
wonderful.
Down below.
The feather is all the way up. We have a predicted apogee of about 289,000 feet.
That is amazing. Our crew looks like they're having an absolutely incredible time, and they are officially astronauts. Welcome to space. Congratulations to John, to Keisha, to Anna.
Hey, I finished the video. Welcome to the space. And I skipped the presentation. And next, we are aiming the past Earth's orbit with the Moon and Mars as our next big goals. The Moon is close, just 384 and 400 kilometers away, and it's where we first learned to live in space. Mars is farther a huge jump at the 225 million kilometers away. Getting there will take many months, and we'll have to figure out how to survive on a different planet. Going to the Moon and Mars isn't just travel, it's us growing as space explorers, testing our technology and our courage to discover more. The Dear Moon project, initiated by Japanese entrepreneur Yusaka Maezawa, is a creative lunar mission aboard SpaceX Starship, designed to take artists on a journey around the moon.
It has been 50 years since Apollo 8 achieved lunar orbit in 1968. The time has come for civilians to fly to the moon. In 2023, SpaceX will launch the world's first private lunar mission with its spacecraft, BFR. The first passenger will be Japanese entrepreneur Yusaku Maezawa, a globally renowned art collector who believes art has the power to promote world peace. Maezawa made a bold decision. A painter, photographer, musician, film director, fashion designer, Maezawa will invite artists that represent Earth on his journey to the moon. The distance to the moon is 240,000 miles. The crew will spend a week in space. What will they feel when they see the moon? When they see Earth in full view? And what will they create? Their works will certainly become a legacy for humankind. An awe-inspiring, global, universal art project is about to begin. Dear Moon.
So far, our journey through the cosmos has kept us within a stone's throw of Earth, where rockets have been our vessels to the stars. When we venture into space just beyond our planet, rockets are the workhorses that carry us aloft. While today's presentation won't delve into intricacies of rocket science, I'd like to highlight a pivotal innovation shaping the future of rocket technology is reusable rockets. Reusable rockets represent a paradigm shift in space travel economics. Unlike the traditional single-use rockets, that serve for a single mission, these modern marvels can fly, return, and be flown again. This advancement is not just a step, but a giant leap towards sustainable and cost-effective space exploration, embodying the very essence of innovation and efficiency that will fuel our celestial ambitions for decades to come. And I show you the interview of the Elon Musk about the reusable rocket.
If you look at, say, the cost of a Falcon 9 rocket, which is quite a big rocket, it's about 1 million pounds of thrust, and it is the lowest cost rocket in the world, and even so, it's about $50 to $60 million. But the cost of the fuel and oxygen and so forth is only about $200,000. So obviously, if we can reuse the rocket, say 1,000 times, then that would make the capital cost of the rocket per launch only about $50,000. There'd be maintenance and other things that would factor in there, and fixed costs and some overhead allocation and whatnot. But it would allow for about a 100-fold reduction in launch costs. And this is a pretty obvious thing if you think about it as applied to any other mode of transport. You can imagine that if planes were not reusable, very few people would fly. 747 is about $300 million. You'd need 2 of them for a round trip. And yet I don't think anyone here has paid $500 million to fly. And the reason is because those planes can be used tens of thousands of times, and so all you're really paying for is fuel and pilot costs and just sort of incidentals, and the capital cost is relatively small.
And the next video is the reusable rocket.
2, 1, 0. Ignition and liftoff.
This is cold nitrogen gas, which helps with attitude control.
Stage 1, London light deploy.
That was as smooth as I'd seen it. We had phenomenal shots all the way through the landing burn. You heard the sonic booms. This booster has landed for the 8th time. That is the 89th recovery of an orbital.
And then I can go to the next slide. A reusable rocket emerged to address the high cost and inefficiencies of traditional launch, where most of the vehicle is lost after one flight. As we aim to explore beyond Mars, we realize rockets alone won't suffice. We need groundbreaking methods like the space elevator, an innovative lift from Earth to orbit poised to revolutionize access to space. For an in-depth exploration of this concept, please see the following video.
To understand how a space elevator will get us into space, we must first understand what an orbit is. Being in orbit basically means falling towards something, but moving fast enough to miss. If you throw a ball on Earth, it makes an arc through the air and then hits the ground. In space, gravity makes you move much the same way, but if you move sideways fast enough, the curvature of the Earth makes the ground fall away beneath you as fast as gravity pulls you towards it. So to enter Earth's orbit, rockets have to go up and sideways fast. By contrast, a space elevator taps into energy from the Earth's rotation to get the cargo going fast. Imagine a child spinning a toy on a rope with an ant on the child's hand. As the ant climbs out along the rope, it starts to move faster and faster as it ascends. Compared to rockets, with cargo launched on an elevator, you only need to provide the energy to go up. Fast sideways movement comes free with the Earth's rotation. But a space elevator would, without a doubt, be the single largest and most expensive structure ever built by humans. So, is it worth it? It all comes down to costs. Rockets burn a huge amount of rocket fuel just to get a small amount of cargo into space. At current prices, it costs about $20,000 to put 1 kilogram of payload into space. That's $1.3 million for the average human, $40 million for your car, billions for an international space station. This immense cost is one of the major limitations of human spaceflight. Even with advancing technology, this cost isn't likely to be comparable with the price of an airline ticket anytime soon. A space elevator would solve this problem. After construction, a space elevator is projected to reduce the cost 100-fold to $200 per kilogram. If an inexpensive space elevator costs $20 billion, then we'll recoup our losses after launching only 1,000 tons, close to the weight of 2 international space stations. So what would a space elevator look like in real life? A space elevator has 4 major components: the tether, anchor, counterweight, and climber. The elevator part of the space elevator is the tether and the climber. It extends from the surface of the Earth to space. The climber is like a conventional elevator carriage, a chamber that works its way up and down the tether. At the base would be an anchor, pinning the tether to the Earth, along with a port for climbers. At the top is the counterweight, which holds up the tether. The tether is held tight like a rope and supported from above by the tension from the counterweight, located higher than 36,000 kilometers above the Earth's surface. At the counterweight could be a space station, a launching point for all missions from the spaceport elevator. But can we actually build one? It's hard to say. The biggest challenge is the tether. It needs to be light, affordable, and more stable than any material we can produce right now. There are promising materials like graphene and diamond nanothreads, but even they may not be strong enough. And aside from being incredibly strong, the tether would also have to withstand atmospheric corrosion, radiation, and micrometeorite and debris impacts. Additionally, it takes several days to climb the elevator. How do we power the climber? It requires a lot of energy to go up. Do we need a nuclear reactor on our...
Okay, I stop the video for the theoretical part. And I go to the next slide. Okay, the next technology is the skyhook. The concept seeks to bridge the gap between Earth and space with dynamic tether system, potentially reducing the energy needs needed for space launches. And also for a detailed explanation of how the skyhook could lead us into the future space travel, please refer to the following video.
This concept is known as the skyhook. It works even better if we make it spin. A counterweight holds a long cable in place while it rotates around a circle. A rotating tether slows down its tip relative to the ground at the bottom and speeds it up at the top like a catapult. This means that you can transfer energy from the tether and get a massive boost when released, more or less for free, equal to twice the tether's rotation velocity. Specialized fibers already exist that can survive the extraordinary stresses a skyhook would be faced with. To protect against cuts and collisions from debris and meteorites, we can thread our tether into a web of redundant fibers. Since our skyhook would pass over the same spot many times a day, this would allow small, reusable shuttles to catch up with it. Of course, it's not that easy. At its lowest point, the tether's tip is dashing through the atmosphere at around 12,000 kilometers per hour. Because of Earth's atmosphere, we can't lower the skyhook too much or it will get too hot from air friction. So it will dip to a height of 80 to 150 kilometers and no lower. To match this, we'll need specialized spacecraft that can get to the tether. While this isn't exactly easy, it's still much cheaper than getting a big tin can filled with rocket fuel to go 40,000 kilometers an hour. Catching the tip will be a challenge too. There's only a short time window of 60 to 90 seconds to find a tiny thing in the sky moving at Mach 12. To make this easier, the tip could have a sort of fishing line, a kilometer long, with a navigation drone that helps the spacecraft connect. Another challenge is keeping our skyhook in orbit. As more and more ships latch onto it and pull themselves up, they use up the momentum that keeps it in place. If we don't do anything, it will slow down and crash into the atmosphere. And here, we can cheat the universe a bit. The skyhook is a battery of orbital energy. It's possible to balance the payloads coming in and being sent off. Arriving ships bringing humans and materials home to Earth add energy to the tether, which it can give to other ships departing into space. This way, the tether doesn't lose any energy. The more we use it, the cheaper it gets. If we're still losing energy with each boost, we can recover it with small electric or chemical engines that regularly correct the tether's position. A set of tethers, one around Earth and one around Mars, could make trips between the planets fast, straightforward and low cost compared to rockets. The Earth tether would sit in low Earth orbit to grab people and payloads and fling them off to Mars. The Mars tether catches them and slows them down for a landing on the surface. In the opposite direction, the tether could pick up a vehicle traveling through Mars's thin atmosphere at only about 1,000 kilometers an hour, not much faster than our airliners on Earth, and fling it back to Earth to be caught and lowered down. The tethers could shorten trips between both planets from 9 months down to 5 or even 3, and reduce the scale of the rockets required by between 84 and 96%. Even better, people may be able to travel in relative luxury, as we could afford to invest in passenger comfort. Tether travel would be first-class seats to Mars. Together, tethers around Earth and Mars could provide the rapid and cost-efficient transportation backbone that would make space travel affordable. But let's go further. Starting from low Mars orbit, a tether could boost ships to the asteroid belt. The first craft sent to a new asteroid would need rockets to slow down at its destination. Subsequent arrivals might find a tether waiting to catch them and send them back for free. Getting to asteroids cheaply is a major factor in opening up the resources of the solar system. Precious metals and valuable minerals could be delivered to Mars just weeks after they were cut out of their asteroid. They would be the perfect building blocks for our interplanetary civilization. But why stop here? Mars moons are very convenient. No other moons in the solar system orbit that close to their planet. Phobos is so heavy that we don't need to worry about slowing it down, making it the perfect attachment point for super tethers just under 6,000 kilometers long. The lower tip would fly just over the surface of Mars and be very easy to catch. The upper tip can fling ships all the way to Jupiter and Saturn. The same super tether can also bring the inner solar system closer. Venus and Mercury are a single swing away. Unlike Mars, they're bursting with solar energy and are rich in minerals. In the long term, nothing is stopping humanity from constructing a zero-propellant transport network for the terrestrial planets centered on the Martian moons. Tethers are a comparably cheap and sustainable solution to making space travel affordable and the rest of the solar system accessible for exploitation and exploration. Considering that we have the technology to build them today, there's really no good excuse to wait any longer. Parts of the solar system are far away, but they could be very close.
Okay, then go to the next part of the presentation. Okay. Advancing our vision further, the orbital links stand as the board architecture fit a proposed structure encircling the Earth, designed to provide a stable platform for launch into the cosmos. The orbital link is a theoretical space megastructure, a giant loop hovering above the Earth's equator. It's envisioned to rotate in sync with the planet, providing a stable, continuous platform from which spacecraft can launch into orbit more efficiently. This concept could revolutionize our infrastructure in space, making travel to and from orbit more like catching a flight than launching a rocket.
Now, finally, we see the orbital ring. I don't know what technologies we will see in between modern rocketry and this concept, but barring a big game changer like anti-gravity or wormholes we can open up from planet to planet like in Stargate, I think this one is the final product of the effort to get people off the ground and up to the heavens. Even things like cheap, compact fusion we could make spaceplanes with doesn't really rival this in terms of volume, because those will produce so much thrust and heat that you could never use millions of them a day on the planet. This system doesn't just get you into space cheap, it gets your whole civilization up there cheap, and lets you truly engage in bulk trade and transport. And that's always been the real goal, not to get a few astronauts to Mars, but to make it so cheap and easy that going to the moon is like flying to another country, and going to another planet takes as much time and money as an ocean cruise. So that's the series wrap-up.
Okay, I show the short part of the video. And I think it is enough explanation for the orbital links. Okay, then finally, let's turn our attention to spin launch. It's an innovative launch system that seeks to catapult payload into space using the massive centrifugal force. This groundbreaking approach could redefine how we reach orbit dramatically, lowering cost and increasing launch frequency. To see this concept in action, please watch the following video. Okay, this is the video for the spin launch. Okay, next, we must go beyond Mars and into the galaxy for our survival and to satisfy our curiosity. Deep space travel is crucial for figuring out the universe, living on other planets, and keeping our civilization alive into the future. Delving into challenges of deep space exploration, we face two primary categories of limitations: technical and human. First, technically, the vast distance and harsh conditions of space push our current propulsion and life support systems to their limits. We must innovate to travel faster, sustain spacecraft integrity, and ensure reliable communication across the cosmic void. And on the human side, the psychological and physiological toll of long-duration spaceflight cannot be understated. We must address the effect of microgravity on the human body, the need for sustainable life support system, and the mental health challenges of isolation and confinement. Together, these limitations define the current frontier of our spacefaring capabilities, guiding our research and development as we strive to overcome them. Breakthrough Starshot is one of the ways to overcome these limitations and proceed with deep space exploration. This video shows what is the Breakthrough Starshot. And this is the final slide of my presentation. And starting from the next one, Juno Park will present the next part. Thank you.
Okay, so from now on, we're going to talk about something a little more. We're going to talk about something a little more sci-fi. So you might have imagined for once moving from one location to another in an instant, which we normally call them as teleportation. It would be magical if we could travel far distances without any physical movements. However, it is not easy to even imagine the possibility of teleportation within the current scientific knowledge. Instead, there are some possible and realistic approaches to allow warping through spaces or travel faster than light. First, there is a concept called wormhole. A wormhole is a hypothetical structure that connects disparate points in space-time. The possibility was shown by a special solution of the Einstein field equation. There is yet no observational or experimental evidence for the existence of wormholes that can transfer objects. However, recently a Google team succeeded to make a quantum wormhole while conducting a quantum computer experiment. The quantum wormhole basically
My good friend CGP Grey has made a great video about the practical and philosophical concerns with teleportation. In particular, the concern that when a transporter dismantles the atoms in your body and reassembles an identical arrangement of atoms somewhere else, perhaps the disassembled you actually dies, and the reassembled you is actually a new being that just thinks it's you. And if they simply hadn't dismantled the original you, then there'd now be two yous in the universe. And which is really you? You or the teleported you? Gray's video covers these questions really well, so if you want more background, you should go watch that. But I do have one additional piece of information I'd like to point out, something the original creators of Star Trek were definitely unaware of because it was discovered in the 1990s, and that is quantum teleportation. Quantum teleportation is the only kind of real teleportation technology we currently have access to, and while I won't go into the details here, the point is you can take some particles in a particular arrangement and transfer their exact quantum condition onto other particles arbitrarily far away. It kind of seems like sad teleportation because the particles don't move, just their state. But isn't that essentially what a Star Trek teleporter does, albeit on a larger scale? Sending enough information and energy over to the new location to create the exact arrangement or state of particles that corresponds to you? And quantum teleportation has one pivotal property. It is impossible to create an identical copy of a quantum state without destroying the original. In fact, you have to destroy the original arrangement in order to extract all the necessary information from it to construct the new teleported state. The relevant theorem in quantum mechanics is called the no-cloning theorem. Now, we don't yet know exactly how brains work to create consciousness, but if the quantum states of some electrons somewhere in the brain are critical to perfectly determining, and thus copying, you, then a teleporter would necessarily have to obey the rules of quantum teleportation when sending the information about the arrangement of particles that are you to the new location. So whatever was left behind would definitively not be you. I've included links in the video description. My good friend
The quantum wormhole basically disassembles the original particle and reassembles the particle at the target location. Therefore, transferring humans using a similar principle as a quantum wormhole will be very dangerous. Next concept is Alcubierre drive. The principle of Alcubierre drive is to shrink the front space and extend the rear space so that the vehicle naturally moves from the extended space to the shrinked space. This concept was also shown in Star Trek called warp drive. Since the vehicle is moving by bending the space, the speed can exceed the speed of light because it doesn't accelerate the vehicle. However, folding the space will require extreme amount of energy, and how to bend the space is also a big challenge. This is a simulation video of Alcubierre drive. There are also lots of concerns about side effects of folding the space. Some scientists argue that massive explosion will occur when the folded space returns into its original state. Also, the masses that were trapped in folded space during Alcubierre Drive can explode.
And there are some other reasons we're not all hopping on warp drives and heading off to the North Star right now. Even if you did manage to collect enough positive and negative mass to get the warp going, the ship would be basically unsteerable once you did, because it is impossible to communicate with the outside of the bubble. And even if you did manage to make it to the North Star, your warp bubble would pick up a bunch of dust and light on the way there, and all this space junk would build up a ton of energy at the edge of the warp bubble. So when you go to return space to its normal shape in order to land, all that high energy space stuff would basically blast every living thing at your destination into oblivion. So all NASA's doing now is trying to create teeny tiny warp fields in order to see if this sort of thing is even possible. And if it is, we're still probably a millennium away from actually using it. If you want to learn more, you should check out some of the links below. And until then, and there are some other reasons we're not.
Finally, I would like to conclude with an explanation of the metaverse. Metaverse is an immersive virtual world that is facilitated by the use of virtual reality device, in short VR device, or augmented reality device, in short AR device. Metaverse can provide users experience similar to reality, making them think that they are actually in that situation. Future advances will allow for more sophisticated VR devices that generate less heat and are less heavy, and will enable more realistic interactions in addition to visual aspects. For example, users might actually walk or move, making the experience more realistic. This is a video of traveling various places using VR.
Would you believe it if I told you this was not a video of Pulpit Rock in Norway, but in fact a virtual reality experience, which is absolutely nuts. This is Pulpit Rock in Norway. Look how high that, look, watch, hold on just a second. Look how high up this is. And listen to the wind. Let me turn this sound up. Look how high that is. Like, holy crap. I do not want to fall off of this. Gives me vertigo just standing there. This is all 3D scans of these locations. We're going to be going through some different locations today. This app has been updated several times since it launched, including a multiplayer update, which we will take a look at a little bit later. Look how realistic this looks. This is just one of several we're going to check out today. There are a ton of locations. It's only $9.99 on the Quest store, and it's fantastic. You can actually, you got your little watch here. Watch this. You can actually switch it to nighttime. And now, look at the stars in this place. And look at the moon over there. You can see the moon shining off of the river. But this is pretty freaking fantastic, and it blows my mind every single time I play this game. Look how you can see, literally, let me get on the floor. You can literally see the textures of the rocks on this cliffside. And look, the grass or moss. Jeez, this is a really high cliff. Let's go somewhere else. To travel, you actually just tap your watch. There's a ton of locations. We're going to go to Mount Sunday in New Zealand. I've always wanted to go to New Zealand. Of course, I actually have multiple spots in them. We'll find one here in a minute that does. You can move around in here and just see. Look at this. It's like a valley. You can see the range running all the way around. You actually can take out this compass, and it'll give you information about the place. But this is fantastic. Oh, look, there's birds up Pine Peak. And this is in the U.S., actually. Man alive, that's some steep rock. How in the heck would one get up here? I guess you'd have to have some real climbing gear to get up here. Look how far down that is. You can see the clouds moving because we're high enough up for the actual clouds to be around us over there. You know what else is awesome too is you can actually take photos by holding your hands like this, and it gives you this little picture thing. So you can actually position it where you want it, and then you can zoom in if you want, reframe it. Butterfly up here. Holy crap, look at the clouds down there. We're now in South Korea. I'm going to attempt to say the name of where we are, which I think it's something like Ulsanbawi. I have no idea how to actually say it. Look at all the butterflies up here. I thought I just heard a bug flying in my ear. But look at that. Look at the cloud coverage as far as the eye can see. Holy, look at the sun over there. We're really high up again. Some of these locations are like in valleys, so you can see the mountains, And some of them are on mountains, so you can see the valleys, which sounds obvious. But listen, listen. You know the birds down there? Wow, that's awesome. I would never be able to see stuff like this. See, this is the thing, okay? Number one, I'll probably never make it to South Korea in my entire life. More than likely. You know what I mean? And number two, I'm never climbing a mountain like this. Like, look at this. Oh, there is a mosquito in my ear. I can hear a mosquito. Look at this. I would never in my life attempt to climb this. So the fact that these people have made it possible to actually experience going to these locations as much as is possible. And I've actually got a video coming out very soon that'll make this even more immersive, and we're going to talk about that later on. Has to do with scent. I'm not going to give anything away. But if you had a fan on you, like a strong fan, let's check another location. Oh, wow, this is a totally different type of place. We're in France now. Look at these rocks. Oh, wow, that's beautiful. Look at the valley running through that passageway right there. You can hear the water. See the clouds moving? It's got like a waterfall going there. See it moving? You can actually hear it coming down the side. It's very loud. You got some more water there. You can hear it very loudly. There's water dripping right there and right there. Oh, it's going right down the whole face of the mountain. This is like Cirque de Gavarine. Okay, so see, this is what I was talking about. Go to Wall Street? Oh, we're headed to Wall Street. Okay. So to go to locations and to get information, look at the walls in this place. Look, there's actually a plane going up there, a jet of some kind or something. All right, so you can freely move down here, and to go to new location, right? And you could take your classroom with you and go through and say, okay, this is what this is, and this is what that is. That's pretty impressive, really, and I think that's going to be the future of education. This would be kind of creepy at night because you get very little light in here. Oh, let's try it. Yes, confirmed. Creepy as all get out. Let's get out of here. All right, since we're already in Utah, I figured we'd check out the Singing Canyon. Listen. Does the canyon sing? I've never heard of Singing Canyon before. Like, does it actually, is it like a chamber where wind goes through and it sings? Is that what it is? Yes, I get it, Seagulls. I can hear you. Ooh, Lee, this is a weird place. This is called Goblin Valley. And this is in the U.S. and Utah, too. Can I climb up here? Oh, I fell down. No. You can hear the wind whipping through this. I kind of want to go to Utah. You know? Just to see all this stuff. I kind of want to go to this in real life just to see it. But then again, there's probably snakes and stuff there. Like rattlesnakes, maybe? Or
You know what? It does look like a road a little bit.
Need to find some dirt bikes and make our... Would you believe it if I told you this was...
Now we'll conclude our class by starting the discussion. Thank you.
Yes, thank you so much. And yeah, as usual, we're now going to take a short break to digest that and to think about the discussion points. And then maybe in 5 minutes, we will resume and ask the other students to join the discussion, to share their thoughts about this great presentation. So brief break right for now. Please keep the discussion slide online and feel free to turn off your video for the 5 minutes. Thank you so much. Yes, hello and welcome back to the discussion of this great presentation. Great, I really must say this was mind-blowing. Excellent, excellent job done. Very original thinking. And also, yeah, I notice you're all students in computer science, but the presentation went far beyond maybe to engineering disciplines. I'm really impressed. Yeah, but that being said, let's join the discussion. And there are 3 suggestions on what to think about and what to share your thoughts about. So now is the time for the other students, the non-presenting students, to speak up. Please raise your hand or just unmute yourself and start talking. This is a safe zone. There's no wrong answers, no wrong comments. Please take the courage.
So I was intrigued by the third question. I think it's very important to analyze and discuss. Recently, as the metaverse has developed, some people go on trips in the metaverse. Can metaverse travels actually have the same effect as going on a trip? So I'd like to respond in two ways. First one would be from work perspective. Personally, I hate meeting offline and discussing work, whereas it could be done online, and I don't have to spend my time going, dressing, and so on. So in this sense, metaverse is very beneficial. However, if we consider trip as like spending leisure time, then I would consider that day-to-day life and real journeys, they should always take precedence. And because time spent in the metaverse is time not spent outside. So is it like, do we really, as people, as humans, want to embrace the real world challenges to solve space travel, climate, and like universe travel, or do we want to trick ourselves into like fake this self-actualization, like maximal dopamine, endorphin, oxytocin triggers via these hyper-realistic simulations? Of course, we can enjoy. Like personally, I played Minecraft a lot, and I was amazed by the like world of it. And we also can consider even books, fictional worlds as being some form of metaverse. But always we need to remember that we have our own life, which is always like the supreme form of anything, especially of trip, of travel. And I don't think any virtual form such as metaverse, books, or video games, they can be on par with trip in real life, because we're limited by our own imagination and our own implementations of these methods.
Thank you. Yes, that's a very important point. And some of you might remember this movie Player One, right? Where the real world is basically garbage, everything is polluted, and instead the whole population flees into virtual worlds where everything is nice and pretty. Yes, and that's what Damir has been maybe warning against. Thank you. Good point. Other comments? So this is no criticism, right? This is it's good to share different opinions and different thoughts. How about discussion points 1 and 2? Do we have some students ready to share their thoughts on that? I think Jimin just turned on the camera. Jimin, do you have some thoughts?
I have a question. Can you hear me?
Yes.
I have a question about the first one. Know that there's a lot of space waste outside the Earth. I mean, on the Earth's orbital. So, for building the skyhook or some space transportation things, we have to consider those space waste that they would break down our transportation. So, how are we going to deal with those problems? I want to ask this.
Yes, so you're asking about space debris, is maybe the technical term. That's a question maybe for the presenters. Song, you want to unmute?
We are so thought about that, but now we don't have an idea for that. Yeah.
Fair enough. Right. Maybe the altitude at which this space debris occurs is not the this is basically where the Earth's centrifugal force and the gravitational force cancel out, and maybe with skyhook or orbital rings, this is a very narrow band where this accumulates. Right below that, space debris will eventually fall down back to Earth, and beyond that it will go into space. And so maybe this is just a very narrow band where this danger occurs. Maybe, I'm guessing here. Anyway, yes, thanks. And how about discussion point 2? Do we have some thoughts or opinions on that to share? That's basically a social question, right? So how would societies organize outside of the Earth? Or maybe also a question of who would be eligible and able to afford moving outside of Earth, right? So in some science fiction movies, it's the kind of a punishment, so the to be sent outside of Earth, right? So it's the disadvantages or to be considered for moving outside of Earth. And in other science fiction movies, it's the opposite. Though everybody who can afford leaves the waste place Earth and moves outside, and those that remain are the unfortunate ones. Any thoughts on that?
The question is, should we make the planet that we're transferring to similar to our own planet? The process is called terraformation. Like, do we really need to make the similar atmosphere and soil to basically replicate the living conditions on Earth? Or should we approach it differently and just adapt to the existing conditions? So, depending on our answer to this question, we will base what kind of tools do we need to take with us, and what kind of lifestyle and we're gonna lead, and what kind of food, and yes, everything will depend on whether we treat the second planet as our second Earth or just completely different planet.
Yes, that's a good point, right? Yeah, so I mean, moving to another planet could be kind of like locusts, right? Locusts, they feed and destroy some local habitat, and then they move on. And are we humans gonna be space locusts? So we have we're about to consume and destroy the environment of Earth, and then we move on to the next planet and use and destroy that. That's actually something that is in some, right? Do you remember the movie Independence Day? That's where the aliens are accused of acting like locusts, moving from planet to planet and consuming them. And maybe it's actually us humans who are destroying one planet and then moving on to the next one. And we don't want that to happen, right? Yeah. So thank you, Damir. That's also a very good comment. Yeah, time is running up. We have a few more minutes left, so if you want to add something, please feel free to do so now. Give you a chance. Anybody?
I would also add more on the second question.
Yes, can you turn on your camera?
I'm sorry, but I have like, can I do it without camera?
Sure, yes.
Thank you. So it indeed would, like, as the professor have said, the equity and equality problem would also arise because of the not unfair I'm sorry without the unfair opportunities of the people that have. And also I think people should be considering the question of legal frameworks, like how are they going to establish the space laws, because it's not the one country that does the space colonization, but like international collaboration of countries. That's why it could get some kind of hard for people to find a common ground on those laws. And also, as you've already mentioned about the indigenous, like native species to these planets, like as we know, as people colonize other places, they also destroy the native species, the people, indigenous people. And I am afraid that it could be also the case with the space colonization. So that's why we should consider like not avoiding those kind of problems.
Yes, that's two excellent points. Thank you so much, Tilnas. So you point out first about laws for space, right? If there is conflict, and from all our experience, conflict is going to be inevitable, right? We're having conflicts even on Earth, where there's lots of distance between, let's say, Soviet Union and United States, and still there's conflict. And when these countries or representatives of these countries move to space, maybe there will be conflict, and we're going to need laws for that. That was your first point. And your second point was about, right, so when Europeans moved to America, there was a rich culture of Native Americans in the northern part and in South America, right? There was the anyway, yes, and it was all destroyed, right? So the both deliberately with firearms, Native Americans were killed, but also like the flu, which was Europeans were immune against, but they infected the native population, and many of them died. And now we have very few Native Americans living in their own country, maybe in reservations. And the danger is indeed imminent that the same will repeat, and we should learn from the mistakes of the past and maybe put them into laws, space laws, before these mistakes start to repeat. So that was your 2 points, right, Dildas?
Yeah, thanks.
Yeah, awesome. Very important observation. Right. So yes, thank you so much. Today was really an exciting and interesting session. And so that's all for this week. That's all for topic D, future of transportation and travel. And next week we will learn and talk about the future of societies and value or belief systems. And this will be given by Dongwon, by Hallelujah, and by Nurul Sultan. So these three, please remain online. Few more minutes, and the rest of the class is dismissed. Thank you very much, and have a great weekend. And see you. Right, and let's thank the three presenters from topic D once again. Thank you, Dongyu. Thank you, Junho. Thank you, Min Sung.